The first step in the design cycle is identifying the problem, which was laid out for us by the Fountain project page. Also part of this step was exploring the problems, which we did through extensive research regarding water pumps, history of water fountains, and pros and cons of water fountains. Next, we had to brainstorm ideas to tackle the problem. We brainstormed a few ideas that included having a tiered system that water would run down, and another idea was having a water wheel actuate movement. We settled on this design because we felt that we wanted to be challenged appropriately. We decided that we would use an electric pump to move the water, so we had to meet one of the other design requirements. We chose to achieve this goal by having a water wheel actuate movement. Next, we went to the resource room to collect various resources that we thought may help us complete the project. We started with creating the water wheel by taking 2 wooden rings and gluing spokes to them and connecting them with flat pieces of wood to catch the water. Then we created the aqueduct system in an L shape. Next, we would make a wooden square base that we could attach the aqueducts and water wheel to. After this was all attached, we had to make the inner workings of the water fountain. We first started with an aluminum pan that would catch the water off of the water wheel and would run down a PVC pipe that was glued to the pan into a Tupperware container that was acting as a water reservoir. Then the pump was placed in the Tupperware container and the tube was run vertically to match the height of the aqueducts. The final step was sealing all the wood with Flex Seal to ensure no leaks. Finally, after all construction was complete, we did final testings and made the final adjustments that were required to optimally perform the water wheel.
One design challenge we faced was in creating the water wheel. At first we tried soaking 2 strips of wood in water and bending them around a circular form to mold them into shape, but we found it was very difficult to bind the 2 ends of the circle together once it was formed. This is the one on the left in the photo, and it was too far from a perfect circle to work for the water wheel. We spent a lot of time trying to find a solution to this, but in the end we had to purchase circular wooden rings that were already shaped so that we could continue with the construction process, and these are pictured on the right. Another big problem we had in making the fountain was making sure all of the water stayed inside of it. Initially, some water leaked through the base, so we had to revise the design, and instead we held the water in 2 containers with a pipe connecting the 2 so that the water was not held directly in the base. We then flipped the wooden base upside down so it covered these containers, and we built the rest of the fountain on top of that. We calculated the energy used by our pump to fulfill the equation requirement. Energy is equal to power in watts multiplied by time in seconds, so we found how much energy our pump used during the duration of the FEDD competition, which was around 2 hours, how much it would use in 1 year, and its energy usage in comparison to a standard light bulb. We used a 3-watt water pump in our fountain, and a standard light bulb is around 40 watts, so in 1 year we calculated that the light bulb would use significantly more energy to operate constantly.
That's awesome. How did you figure that out? You said
The whole rod is the
Our fountain project went into the competition holding up very well. But as the day went on, we discovered more and more flaws to the wood design we created, such as warps in the wood, and because of the weight of the water, the stands holding up the directional shafts. Initially, the fountain held up very well, and if we were judged within the first 10 minutes of the competition, we would have done very well. But the first piece of damage we found in the design was the warped wood near the top of the project where the wood split and allowed water to come out. We fixed this by hot gluing the wood together and sealing off the exposed area. Second, we found the angle of the waterfall leading into the water wheel was too far and no water hit the wheel, so we removed the stands holding it up and pulled it back and hot glued them from there. Our third and final flaw we found was with the water wheel itself. The weight of the water and absorbency of the wood allowed the wood to take on greater weight, breaking the hot glue bond between the small stakes and the wheel itself. Overall, our project was designed well, but did not do the best it could in competition.
If we could do the project over again, we would find a better way to seal the aqueducts to prevent leaking. We used hot glue along the seams of the wood, but it got messy quickly and could have looked much better if we had used something else. Also, we would have started earlier so that we would have had time to include other aesthetic elements and made the fountain look better. For example, we might have painted the aqueducts or the base to match the theme. Finally, we would change the material we used as supports to hold the aqueducts so that it was much more stable.
Some advice our FED group would give to future students is to first and foremost be prepared for anything. The engineering design process can be very time-consuming and you can experience many errors and setbacks. However, it is important that you are not afraid of failure. While an idea may seem to work in your head, it could be harder to execute in real life. Therefore, it is essential that you consider all options before beginning construction of your project. Additionally, it would benefit you to set specific times each week to meet with your group. This could be to either complete the research portion or to touch base on the building process and discuss issues that may have arrived. Communication is key in this project. We also found it helpful to go to the workshops that NC State provides. Not only can attendance award your group with extra credit, but it can provide you with other perspectives on how to complete the project and give pertinent information that you may have missed, such as, in our case, the formula for energy that our fountain uses. Finally, before the day actually comes, it is important to test your project in order to ensure that it is in the best condition for the judges.